This is session 0224 for College Algebra M111. The topic today will be first midpoint and then circles. Okay, here's your midpoint formula. You can also find this midpoint formula on page 30 of your handout packet. What we are doing today is if we are given 2 points on any line, we can find the midpoint of that line using coordinate values. Now, if you think back to diameter and radius, the diameter is all the way across the circle. The radius is halfway across the circle. So you would take the diameter, divide it by 2 to get the radius, which is, in that case, the midpoint of the diameter. The center point would be. Now, in this formula, you have 2 sets of values. What you have here is actually a coordinate. Here is the x coordinate, and here is the y. What we're doing is we are adding the 2 x values of the point, dividing them by 2. Then we are adding the 2 y values of the point and dividing them by 2. What we're really doing is we are averaging the x values and averaging the y values. In other words, add them together and divide by 2. Okay, here's our first example. Find the midpoint of this line segment with these endpoints. Okay, so I'm just going to arbitrarily call this point 1 and call this one point 2. So here's what I would put. For the x values then, if this is 0.1 and 0.2, what I have here for the x's is I have this x value plus that x value divided by 2. For the y's, I have this y value plus that y value divided by 2. Well, these arithmetically simplify to 1.35 and -2. So the coordinate of the midpoint between these two would be this in decimal form or that in fractional form. Okay, we have another problem here, but we're going to go ahead and pass on that one. I do want to do one more if the computer will allow me to write on this screen. What if I had the points and it's not, what if I had the points 2, -3, and I had another point -5, 7. And I want to find the midpoints of those. Well, I'm arbitrarily going to call this 0.1 and 0.2. So I'm going to have here, in this case, the x values, I'm going to have 2 minus -5 all over 2. Then I'll have -3, or plus, excuse me, right here. This should be a plus sign because you're adding these. -3 plus 7 all over 2. And that's the when we simplify it, will be the coordinates of this line segment. So we simplify this further. 2 minus 5 gives me -3 over 2. And -3 plus 7 gives me 4 over 2, which simplifies to -3 halves and the whole number 2. So this would be the point, this would be the midpoint for this particular problem. That one up here would be worked the same way, except we've just got a little bit more complicated numbers. Now we're going to go into circles. With the circles, there are two objectives in this, or concepts that we need to have. Write the equation of a circle in standard form, then write the general form of an equation of a circle. So let's put it in standard form. First, the definition of a circle. A circle is the set of all points in a plane that are the same distance from a fixed point called the center. In other words, you could drive a stake in the ground with a rope tied in it, get at the other end of the rope, walk all the way around as far as the rope would allow you, and you would end up with a circle scratched in the ground. Now, the distance from the center of the circle to the outside of the circle is called the radius. Here is the standard form of the equation. This equation is found in your handout packet on page 30, also on page 31. The notation that we use for this is the H and the K are the coordinates of the center of the circle, opposite of whatever sign that they have here because of these negatives. The radius squared in the formula, of course, you take the square root of r squared to get r. And we only use the positive. We don't use the negative because distance being a positive value. That's what this says. It's the r has to be a positive number. Okay, here's our first example. Graph a circle with this center point and that radius. Here's the general form. We substitute the 3 opposite of sign, and we substitute this 2 opposite of sign. Notice we've got the squares here. And then 4 squared is 16. So this would be the formula or the equation of the circle with its center here with a radius of 4. Now, to graph that, first we put the center of the circle. We graph it. That's the point -3, 2. Then, since the radius is 4, we count 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and then we connect the dots, hopefully in a smooth curve, so that it looks like this. Now, when you're working in ALEKS and doing circles, be certain that you use the magnifier tool. That way you can more precisely place the circles and you won't get counted wrong accidentally. Our next problem, the center is at the point 0, -3, and we have a radius of 2. To write the equation, well, opposite of sign of 0 is still 0. Opposite of sign of the -3 is +3. And r squared of 2 is 4. So here's the equation of our circle. Now this can be simplified because x minus 0 is just x and then we square it. So if you see one that looks like this, an equation of a circle that looks like this, or if it just had a y by itself with the square, then that tells you that the x value or the y value, depending, would be 0. Now we're ready to graph this. We've got our point 0, -3. So we're going to graph it here. Our radius is 2, so we count over 2 in all 4 directions. And then we connect the dots to create our circle. Write the equation of a circle in standard form and then graph it. They give us the center and the radius. Okay, here is our equation. The x value opposite of sine, the y value opposite of sine. These two squared, of course, and r squared being 9. Here's our center, 4, 3, over 4 up 3. Our radius, we count over 3 in each of the 4 directions. And then we play dot to dot. I'll give you a moment to copy this if you wish. Okay, another problem. In this case, we'll go ahead and work it here. There's the general formula. Now we're going to replace the h and the k, opposite of sine. That's a negative. So this is a negative right here. So we're going to have a positive k here, squared, and 4 squared. Oh, I need to put the 1 here. I'll just scribble that over as a 1. And then we have the 4 squared here, which is 16. So there is the equation of our circle. Now they want us to graph it. So I have a piece of graph paper. I find the center, 3, -1. 1, 2, 3, -1, right here. Now, my radius is 4. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And then I try to draw this pretty nice curve. And it's real hard to do with this stylus. But hopefully you get the idea on this. Another one. Here's the center. Now, this says tangent to the x-axis. They don't explain to you what a tangent is. If you have a circle and a radius, here goes the arc of the circle. A tangent would be a line that comes here, just touches that at a right angle to the radius, and it only touches the circle in the one point. Now that's what a tangent is. Now, with knowledge of this, we can try to figure this thing out. Okay, it says, it doesn't tell us, although it does down here. In the original problem, it didn't tell us what the radius was. It says it's just tangent to the circle or to the y-axis. Well, here's the y-axis. So that means it's going to touch in this one point right there. Okay, so that means our radius has to be 3. So 1, 2, 3. We've got the 3 over here, and 1, 2, 3 down, and 1, 2, 3 up. And for some reason, this point keeps wanting to disappear. So I try to draw my circle tangent to that, kind of more like that. Here's the equation of the circle, fully written out. We figured out that the radius is 3, so we can put that 9 in there. And then there's their circle that's prettier than mine. All right, now let's go about this a little different way. They've got this general form thing, and you can factor it and complete the square. But that's not a requirement of this course. Now, what we're going to do next is just the opposite of what we did before. Now, instead of giving you the center and the radius, we're going to give you an equation, and then you have to find the center and the radius. Or in other words, if they gave you this, then here would be the center. Okay, now, also, if this equals 0, then the radius is 0, and it's just a single point. What if you had a negative number here for the radius squared? Well, then it would be imaginary, and you can't draw it. Now, I do want to give one more problem. So let me go in and find a sheet where I can do that. If this will let me back out of this. Okay, there we go. Let me add another sheet to this real quickly. New slide. Want a blank one. And here we go. Now, in this case, I want to give you this equation. X minus 4 quantity squared plus y plus 2 quantity squared equals 25. Now, the question is, what is the center? What is the radius? And then graph it. This is just the opposite of what we were doing before. Well, here's my x value of the center, opposite of sine. So it would be positive 4. Come on, pen, work. What's going on here? Okay, I guess my pen battery must have died or something, because it's decided it doesn't want to write anymore. Let me try a different color ink. The pen's not activating at all. I don't think I can write with this. We'll try. So here I get a 4. No, it won't let me. It won't let me do that. Okay, so there we go. 4 and negative 2. trying to write with my mouse, and actually that's almost better than what I was doing with the stylus. Now, what about my radius? Well, I have to take the square root of that. So the radius in this case is 5. Graphing. Over here is about 4. Here's about -2. I go over 5. I go over 5 this way. Actually, this problem looks a whole lot like the last one. And 5. And up 5. And then I try to draw the circle. Actually, that's about the best circle I've drawn all day. Okay, well, that being done, that's the material that we want to cover over circles. What are the objectives for this? 2 things. One, we want you to, if they give you the equation, we want you to be able to find the center of the circle. Also, we want you to find the radius and to be able to graph it. The other thing we want to do, if we give you the center of the circle, and then we want to have you write the equation and graph it. So those are our primary objectives. And I do want to kind of do this one because of the language in it. Write the standard form of this equation where the endpoints are the diameter of a circle. Okay, these are the endpoints of the diameter of a circle. So in other words, whoops, I'm going to have to get out of this again so it'll let me write. I've got a graph paper. Okay, here is -3, 3. And here is -1, -1. Now, those are endpoints of the diameter of a circle. A circle that goes something like this. Now, part of what we've got to do is we've got to find this center point right here, because we got to find that center before we can write the formula of the circle. Okay. Now, we don't know what the radius is or anything like this. Now, let's do this. We've got to go through some steps. First, we need to find the midpoint of these 2 points. So we've got -3 plus -1 all over 2. And for the y value, we've got 3 plus -1 all over 2. So this thing gives us simplified the point -4 over 2 and 2 over 2, which finally gives us the point -2, 1. And that represents the center of this circle. That's a 2 right there. Now, the other thing we need to do is we need to find the length of the radius. Okay? Well, we could use these 2 points and divide the distance between these 2 points in half, or we can use one of these and the center point, and that'll give us the distance. So to find the distance then, we're going to take the square root of the difference of the x's, so -2 from the center point minus -1 of this point squared plus, now the y values, +1 minus -1 squared, which equals, these give you a pair of positives, and likewise so do these. Now, on this one, so I have -2 plus +1, which gives me a value of -1. Now my pen decides to change colors. Squared plus, and +1 plus +1 is +2 squared. So I get the square root of 1 plus 4, or the square root of 5. Now, square root of 5 is an irrational number, and it's approximately, if I remember, 2.232, but just to be sure, I'm going to check it real quickly on my calculator off to the side. So square root of 5, 2.236. My memory had failed. Equal is approximately, remember we have to use that anytime that it's not exact, 2.236. Okay. Now let's write the equation. We've got the center, -2, 1. So the equation is x minus -2 squared plus y minus 1 squared equals, well, if that's the radius, then this is the radius squared. It's 5. Okay. 5 is that thing right here squared. So let's simplify this and we'll have our final answer. X plus 2 See, that's why I always say the center point opposite of sine. It's because of this double negative thing. Plus y minus 1 squared equals 5. Okay. And this one does not ask us to graph the circle. So at this point, just momentarily, I'm going to have to call it into the class. So rest in peace.